So we are starting in lesson 3.6, Mathematics of Finance. Where it fits in is these are exponential equations. That's why it fits into this chapter, okay? Might even need logs to solve, although I'm not sure if we're doing any of those today. Now, the basic formula for interest compounded annually, okay? A, which is the amount that's going to be in the amount that's going to be in the account, equals P, which stands for the principal, so that's your amount you're starting with, right? Times 1 plus R. R is the interest rate, of course, expressed as a decimal, and N represents your years. Now, I'll be honest, I'm really going to kind of skip over this formula. I just wanted to hint at it. This formula only works when interest is compounded annually. How often is something done annually?
Once a year.
Once a year. Okay, so this formula only works when something is done once a year. Now, we're going to look at the next formula. Notice, I made myself notes. I'm skipping example 1. Okay. Not that it's hard, it's just so easy that saving time. Okay. The formula we're going to focus on is this formula right here. Interest compounded K times a year. So basically, instead of just compounding it once a year, it's compounded monthly, quarterly, daily, I don't know, whatever else, we can come up with. Now, so the changes on the formula. You still have P as the principal amount, R is your interest rate. What is thrown in here is a K, and that K is the number of times something is compounded per year. So could we use this formula for annually still?
Mm-hmm.
You can. If something is compounded annually, you'll put a 1 in. If it's compounded quarterly,
4.
Yeah, I had to think what I said. My brain went somewhere else. Sorry. Quarterly would be 4 times a year. I was thinking it said monthly.
Well,
Monthly would be 12 times a year. Are you following me here?
Yeah.
Okay. A is your total amount of the investment. T is years. Okay, so this formula can be used in all cases, which is why I'm going to focus on it today. Basic example here to make sure we know how to use it. Suppose Roberto invests $500 at 9% annual interest compounded monthly. Find the value of his investment after 5 years. What do we know?
P is 5.
Okay, your initial investment, P, is 500. What else do I know?
R would be 9%, so 0.09.
Okay, so 9% is my interest rate. When we put that in the formula, remember percents to decimal, you move the decimal 2 places. Okay, what else do we know?
T is 5.
Okay, 5 years. So T is 5.
K would be 12.
Okay, most importantly, interest compounded monthly, so K is 12. By the way, if you didn't grab a calculator before class began, you will need it today. Okay, so with all of this in mind, it's fill in your formula, and the key is to make sure you know how to plug things into the calculator, right? Not that it's super hard, but there are mistakes that can be made. So my formula I'm using, A equals P times 1 plus R over K raised to the KT. Okay, so P, you guys told me is 500. 1 plus R, 0.09, over K, which is 12, raised to the KT, 12 times 5. Now, in reality, can you just punch this into the calculator as is? Yeah, we have fancy dancy calculators, you can do that. Okay? If you want to do a little bit of cleanup first, you could. 500 is 500. 0.09 divided by 12, I have as 0.0075. You add 1, it's 1.0075. raised to the 12 times 5, which is 60. I would say pick what you want to do, plug one of these two options into your calculator. Fair enough? I will say, in a different scenario, be careful, don't round what's in the parentheses. Okay, so like if you divide this and you get like a repeating decimal or something, you need to work with it and not round it because that can cause a difference in your answer. Okay? What are you guys getting as an answer?
$782.
I see one head nod.
I agree.
Are you okay back there?
Yeah.
You looked really confused at first, so I thought you were going to disagree with me at first.
Well, I was waiting until everybody else got it because I plugged in my
There's a
first.
second, and then like.
Okay. As I said, you know, both are good. That is $782.84. So basically, you have your $500 principal. My $500 principal just grew by $282.84 because this amount is the $500 plus the interest. Okay? Are we good here? Basics? Okay. Let's look at example 3. Example 3. Judy has $500, seems to be my thing today. Invested at 9% annual interest, compounded monthly. Maybe these weren't the best two examples to pick back to back. It's all right. How long will it take for her investment to grow to $3,000? So what do we know here?
A is 500.
Principal is 500.
A is 3,000.
How long will it take it to grow to 3,000? This is my final amount, isn't it? That's A. This is where things change up. This is why we're in this chapter. Okay, we also know 9%. So R is 0.09.
K is 12.
Compounded monthly. K is 12. What are we going to be searching for?
A is 5.
How long? So we're looking for T. And that's where this things change up. This is what you couldn't do back in middle school. Okay, not without just some serious guess and check or whatnot. Okay, so with that in mind, my formula, A equals P times 1 plus R over K raised to the K times T. Have you already filled it in?
Yep.
Okay, fill in what we know. 3,000 equals 500 times 1 plus 0.09 divided by 12 raised to the 12t. And I'm trying to keep moving fast, so stop me if I overlook something. Okay, thoughts of where to begin here?
We have to subtract the 500 over.
Yeah.
Divide by 500.
Divide it.
And why are we dividing the 500 over?
It's being like
Because it's being multiplied, yes? In other words, yes, I want to do something with 500, but it's not subtracted because it's not being added. It's being multiplied. So just like, and we haven't talked about homework questions, probably a bad thing. I talked yesterday at the end of class, I said always isolate your exponent. That's what we're doing here. We're isolating the exponent and what it goes with. Whoops. Okay, so let's do some cleanup. 3,000 divided by 500 is
6.
equals, the 500s cancel. And we have, can I clean up in those parentheses?
Yeah, that's
I'm going with that was going to turn into 1.0075 raised to the 12t.
it tried its best.
Okay. I kind of did 2 steps at once there. Are you guys okay with
Yep.
2 steps at once there? Okay. This is where we're at. Now what?
Oh, science.
My hint is, what would you have done in yesterday's homework? Huh?
Oh.
Except we use log. Yeah.
No,
Left,
We use
right,
Well-
middle.
We put log on both sides.
take the log of both sides.
Mm.
Okay. If you do LERM, it's not gonna get in any better form. Okay, so yesterday, when we have an exponential equation and we can't get those bases the same, our job was to take the log of both sides. So this is why it's in this chapter, right? Because it kind of probably until now kind of seemed like a random, why are we doing this? This is why. This is where it fits. Okay? So log of 6 equals log of 1.0075 raised to 12t. I did drop the parentheses. I didn't really still need those. Now what?
Oh. Can you put the 12t at the
Power property. The whole point of taking the log of both sides is now I can pull this power out front. So I have log of 6 equals 12t times log of 1.0075.
Divide by log of 1.0075.
And?
And 12.
And 12. Now, could you do this in 2 steps?
Yeah.
Okay, if I started with just dividing the log of 1.0075, then you're going to be left with 12t, right? Equals log 6 divided by log of 1.0075. And you can do that, right? You got a calculator, just keep pushing buttons. If we want to make it one step, this is 12 times t times log of 1.0075. So what could we do if we want to get it all done in one step? Divide by the 12 and the log 1.0075. What you do on one side, you do on the other side. Okay? Now, as you go to punch this into your calculators, if you're using a fraction bar, perfect. No issues if you're using a fraction bar. If you're using the division symbol, note we're dividing by 2 separate pieces, yes? If you just use the division bar, you must put parentheses around the denominator. Otherwise, it will divide by 12, but multiply by that log. And we don't want that. Okay? So, make sure you try the calculator so we get it right. What are we getting?
19.993.
983.
And it goes on past that, right?
Yeah.
Okay. Because I guess I've written down 19.98 ... is what I've written down on my paper. How long will it take for the investment to grow to $3,000?
19.
19.20.
Give me a nice, neat answer.
20 years.
20 years. And it's one of those 19 point, it's almost like 19.999. It's 20.
Christmas Eve.
Okay? I mean, more like New Year's Eve.
Yeah.
So, okay. Are we okay with that problem?
Yeah.
Got the basics? Okay. And that's not using any different solving skills than yesterday, is it? Okay. On the back side. To be honest, this was easy because I never do the exponential growth and decay section at the bottom because I didn't get it in the homework. So, we could talk about this problem, but I'm trying to conserve time. Notice this problem would have been asking what interest rate. So here, we would have been solving for R. It's doable. It takes a little bit more work. I'm just not wanting to take the time to go there right now. Okay? So we're going to jump down and do one quick other thing, and we're going to talk about interest compounded continuously. Do you remember this formula? This has a formula all to itself. And you use this formula anytime you see the word
Continuously.
continuously. Not monthly, not annually, not yearly, not daily, not hourly, continuously. When you see that specific word, it has its own formula. PERT. A equals P, which is principal, times E. E is that 2.718, and it's a button on our calculator, right? To the R times T. So interest rate times T. Now, we're going to look at example 5. I'm going to change this, though. Again, just trying to streamline, get the basics across to you. I'm going to tweak it a little bit. Suppose Natasha invests $100 at 8% annual interest, compounded how? Continuously. Now, officially it says find the value of her investment at the end of years 1, 2, 3, 4, 5, 6, 7. That means I'm finding how many different answers? 7. And normally when I teach this, I teach that you could put 1 through 7 in L1 on your calculator. And then in L2 you could put the formula. You remember how we use the table in the calc there? You could do that. Now, not worrying about it. So we're just going to talk about end of year 7. I just want a basic. Do you understand the basic formula?
Yep.
Okay. So what formula do we know we're using? It says continuously, so I know I'm using A equals PE to the RT because it says continuously. What do we know?
P is 100.
P is 100.
Yep.
What else?
R is 0.08. And T is 7. Right?
And T is 7 because that's what your teacher is telling you to use because that's just what we're trying to streamline to. Fair enough? So, plug it in. P, so 100 times E to the 0.08 times 7. It's all about punching the buttons on the calculator. If you wanted to, you could go ahead and do the 0.08 times 7, but you don't even need to.
175. 7 cents.
$175.07.
Oh.
Okay. Okay. Basics. Okay. Part of, I wanted to practice what we've done, but I just wanted to throw these formulas out there to remind you. Okay, just because you won't see them again otherwise this year. So just remind you that that's what you use in certain situations.
Which we're not going to use this the rest of the year.
No, this only comes up in the exponent.
Will
We'll
these
use-
formulas be given?
Are we still using logs?
Yes.
Not a whole lot.
Yes.
Mostly logs just come up in this chapter. But I would say it's more one of those things when you go on, like, I feel like in calculus sometimes we have to randomly pull out logs. Because it's always one of those things the calculus kids are like, oh, these properties we've looked at, they're like, ooh, I don't, I honestly have at some years have copied a page of log properties and given them to them. So, okay, notice what it says down here. No book homework this time. Okay? I honestly don't feel like you have to have the book homework to succeed in this. I feel like it's not bad. Okay? Now, I'm going to hand out the review worksheet here in a moment. On the review worksheet, there are 2 problems that we are skipping. Okay, so I wrote it down here to remind myself. 27 is a graph from 3.4 that we skipped the other day, so we're skipping it now. 39 is like example 4 up here that I didn't take time to do today, so we're going to skip it on the review. Okay?
So does that mean there's not going to be very much questions on